Okay, so this is States of Matter Part 2. So we are going to go over temperature conversions in this video. So we're going to go over 2 practice problems, one of each type. So first thing we need to know is what is the temperature conversion? So the temperature conversion, you'll see Celsius and you'll see Kelvin. So we always try to convert to Kelvin. So the way we do that is Kelvin is equal to the degrees Celsius plus 273. So the first type of problem we'll see is convert 56 degrees Celsius into Kelvin. So we can go ahead and start setting up the problem. So we know Kelvin is equal to, plug it in, 56 degrees Celsius plus 273. As I go through and add them together, I find that Kelvin is equal to 329. So this 56 degrees Celsius into Kelvin is 329. And we would just put in a K there to represent Kelvin. Second part is now we have to actually calculate the factor by which kinetic energy changes. So kinetic energy can either increase or decrease, and we have to figure out if it's increasing or decreasing and by what multiple. So here's the first type of problem. It reads, by what factor does the average kinetic energy of the molecules of gas in an aerosol container increase when the temperature is raised from 27 degrees Celsius to 627 degrees Celsius? So anytime we calculate factors, you always put the final divided by the initial. But the only thing is we always have to have the temperatures in Kelvin to do this. So here we have Celsius. So the first step is we need to convert. So let's convert both of those. So 27 degrees Celsius plus 273 gives me my initial, which is, when I add those together, 300 K. And then my final temperature is 627 plus 273 to get it into Kelvin. And that will end up equaling 900 Kelvin. So again, to find the calculating the factor, we would take the final temperature and divide it by the initial. So 900 divided by 300 gives you a number of 3. So it went from 27 to 627, so we know it increased, and increased by a multiple of 3. So your final answer is increases 3 times, or a factor of 3.